Welcome to True Projects. In this video, we are going to explain about the project that is Flight Delay Prediction, a dissecting review of recent studies using machine learning. So before getting into the execution, first let us understand what is this project about. Flight delays, which are one of those things that affect everyone in air travel, airlines, airports, and passengers. For airlines, a single day can mess up the entire schedule. For example, if one plane leaving Atlanta is late, it might miss its the next flight in Paris, which means passengers waiting there could also be delayed. Airports feel pressure too. Busy hubs like Heathrow or Atlanta have limited gates and runways. So one late flight can cause a chain reaction, making other plans, that is other planes, wait and creating a messy backlog. Passengers, of course, are the ones who feel it the most. They miss connections, sit in the crowd lounges, and sometimes even have to change their travel plans entirely. And there are many reasons for that, and they are often connected. Bad weather like snowstorms in New York or heavy fog in Singapore can make flying unsafe and unpredictable. Sometimes it is simple infrastructure issues, too few runaways or taxiways to handle all the flights. But the really tricky part is how interconnected the whole system is. A small delay in a major hub can ripple across the globe. For instance, a flight delayed in Frankfurt could cause people to miss connecting flights in Tokyo or New York, even if their journey never touched Europe before. That's why flight delays aren't just annoying, they can create widespread chaos that airlines and airports have constantly managed. And despite all these problems, that is, even though there are tons of flight data available today and advanced predictive models exist, forecasting flight delays accurately is still really tough. The problem is that delays happen for so many different reasons, and these reasons often interact in complex ways. For example, a storm in city combined with delayed incoming aircraft from another hub and full runaways at the airport can all happen at once and affect the flight schedule. On top of that, data sets can be imbalanced, meaning there are far more one time flights than delayed ones. That is, there are far more one time flights than the delayed ones. And flight data has many features like weather, aircraft type, and airport congestion, which makes modeling harder. Researchers, they have been trying to tackle this using machine learning, but there are still gaps. Many modeling, that is, many models work well on specific data sets, but don't generalize to others. Some are sensitive to unusual conditions, and others like that is other models are like black boxes, making it harder to understand why a flight was predicted to be delayed. Because of these challenges, predicting delays reliably is still a ongoing research problem. The ultimate goal is to improve prediction accuracy and provide practical insights that airlines, airports, and passengers can use to reduce the negative effects of delays on air travel. And here in the project's base paper, the author didn't build a flight delay prediction system themselves. Instead, they went through recent studies and analyzed how other researchers used machine learning and deep learning models to predict flight delays. Their main goal was to understand and compare different approaches, highlighting trends, challenges, and the effectiveness of various techniques. Essentially, they focused on reviewing and summarizing the existing research rather than creating or testing models on their own dataset. So, as the extension, we are building upon the initial survey based study. So, this project extends the work by developing a practical system for predicting flight delays using real world data, that is, publicly available flight data set that is collected and processed to ensure quality and consistency. The main aim of this project is to provide an accurate and reliable solution for forecasting flight delays by leveraging a combination of machine learning and deep learning techniques, enabling airlines, airports, and passengers to better anticipate and manage potential disruptions. So, here, the system is built on two things. First, figuring out whether flight will be delayed or not, that is classification. Second, estimate how long the delay will it happens, that is regression. Before feeding the data into models, a lot of cleaning and preparation is done. And here the missing values are filled or removed, duplicate records are deleted, and only the most features, that is, most important features, are kept so the models can focus on what really matters. Since delays don't happen equally often, The data is also balanced using method called k-means mode technique, which makes sure that the models don't get biased towards flights that aren't delayed. After the data is ready, a variety of machine learning and deep learning models are trained. This includes both the traditional approaches like random forest, XGBoost, and neural network models like CNNs, LSTMs, and BiLSTMs. So, using multiple types of models helps the system learn the complicated ways in which different factors like weather, airport congestion, and flight schedules interact to cause delays. This way, the system can make predictions that are not only accurate but also able to handle complex reality of air travel. And for predicting whether flight will be delayed or not, classification task has been used. So the goal is to determine the delay status as accurately as possible. So here we are using classification task for telling whether flight will be delayed or not. So several different models were tested in the end. Voting classifier proved to be the best one, achieving highest accuracy. This means the system can reliably tell if the flight is likely to be delayed or it will be on time. And for predicting the actual length of the delay, the regression task has been done. The aim is to estimate how many minutes a flight would be late. Here, the stacking regressor performed better than the other models, achieving the high R score. This shows the system is not only able to predict whether a delay will happen, but it can also give a fairly precise estimate of the delay duration, making it more useful for airlines, airports, and passengers to plan ahead. And here, to make the system more transparent and understandable, explainable AI techniques like LIME and SHAP are used. These methods help to show which features, such as departure time, weather, or airport congestion, most influence the prediction. This way, the system doesn't just give a result, it also explains why a flight is likely to be delayed or on time, making the predictions interpretable or for users. And in addition, a web application has been developed using Flask framework to provide a user-friendly interface. Through this application, users can enter flight details and instantly receive predictions for delays. The system also provides explanations for these predictions, combining accuracy with interpretability, making it practicable and easy to use for airlines, airports, or any other users. So, this is how we have proposed in this project. This is what we have done in this project. Now, moving on to the implementation. To implement this project, we have followed the steps which are mentioned in the flow of work. So, let's understand them. First step involves importing all the necessary Python libraries and packages. So we will be importing them. These include tools like data handling, pre-processing, visualization, machine learning, deep learning, and explainable AI. This setup ensures that all operations from cleaning the data to building models and visualization and all the performance evaluation will be done. Coming to data collection, so the publicly available flight delay dataset is collected for this project. Once collected, the dataset is explored to understand its structure, the type of features it contains, and how flight delays are distributed. This step helps in identifying potential challenges such as missing values or imbalanced datasets, that is, imbalanced classes, and provide insights into which features might be most useful for the prediction. Then comes data pre processing, where data pre-processing is a critical step to make the dataset suitable for modeling. Null values and duplicate records are removed to ensure data quality. The most relevant features are selected manually to improve model efficiency and reduce noise. Categorical data like airport names or flight codes were converted into numerical values using label encoding. Additionally, for classification tasks, k-means mode technique was applied to balance the dataset, preventing the model from being biased towards majority class. Then comes data visualization. So visualizing the data, it helps in understanding patterns and relationships. The distribution of classification outcomes, that is one time versus delayed flights and regression targets, are examined. Feature correlations were also analyzed to see how different factors such as weather conditions or airport congestion relate to flight delays. These insights guide the feature selection and model design process. Then comes model development. So here, multiple machine learning and deep learning models are developed for both the classification and regression. For classification, the goal was to predict whether a flight would be delayed or not, and regression time, that is regression model, is for predicting how much time will it be delayed. And all the models will be trained. So here, All models are trained on the pre-processed dataset and their performance was evaluated using appropriate metrics. Accuracy, precision, recall, and FN score for classification, MSE, RMSE, MAE, and R score for regression. That is R squared score for regression. Comparison graphs were generated to visually identify which models perform the best. This step ensures that most reliable models are selected for the deployment purpose. Then coming to the explainable AI part, to make predictions understandable, LIME and SHAP were applied. These techniques highlight which features had the most influence on a prediction, making the system interpretable. For example, they can show whether departure time, weather, or airport congestion was the main reason behind a predicted delay. And coming to the front end part, a user friendly interface has been created using Flask. It includes user registration and login supported by an SQLite database. Users can input flight details, which are pre processed before being fed into the train model. The system then provides predictions either as delay status and then it will predict the expected delay duration, making it practicable for the use. Moving on, these are the algorithms which are used in this project. So this is how we have implemented the project. To implement this project, we need two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute it. To execute, so let's open the code folder of the project. These are the source code files in the code folder of the project. Let's understand each of them. So in this we have flight delay prediction dataset. So this is the flight delay data. Get back. Or else let's see what do we have in the data. So this is the dataset that is used in this project to train the all machine learning and deep learning models. Now close it. Get back to the code folder and come back. This is the model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. And this is the static folder in which we have CSS, JavaScript, and Bootstrap files which are important for the visual appeal. And this is the templates folder in which we have all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And in this, we have test cases that we will be using in the front end. And this is the app.py file. So this .py file, it contains information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And these are the two Jupyter Notebook files which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this file is the database file, which is used to store the user information. So this is all about the code folder. Now let's execute it. So copy the path of the code folder from the address bar of the file explorer. I have copied it. Now open Anaconda prompt. So it is open. Give the command cd, give the space, paste the copied path. Now click on enter. Here, if you observe, current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application at the default address, which is the local host and the port unless configured differently. So this is the address where application has been hosted. And this is the local host and this 5000 is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I've copied it. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So now we need to get signed up. Click on sign up and enter all the necessary details to create an account. I have already created, so I'll directly log in. Give your username and the password. Now click on sign in. We are redirected to prediction page of this project. So here you can see inputs, right? So these are the parameters that we are supposed to give as input. Based on that, we will be predicting flight delay. So the first one we will be having is the month, that is the day of the month. It is a day of the month when flight is scheduled. It helps to capture trends or patterns related to specific days. So here we have day of the month, and here we have month. And here we have day of the week. So this is a day of the week, that is 1 to 7, Monday 1, Tuesday 2, like that. Weekdays and weekends often have different flight volumes and delay patterns. Then we have distance. It is the distance of the flight in miles or kilometers. Longer flights may have more variability in delays. And here we have departure delay. It's the departure delay in minutes. A delay departure is often strong indicator of a arrival delay. Then we have maximum temperature. It is the maximum temperature at the departure airport in Fahrenheit, that is in Fahrenheit, where the conditions can affect flight operations and cause delays. Then we have precipitation, and we have average wind and scheduled turnaround time. So this is all about the parameters. Now let's enter them. For that, test cases, open test cases, open sample file. So it is open. This is the target that will be predicting. Apply filter to it. So let's apply filter to class 0. Click on OK. And now let's keep it aside. Let's start entering them. So let's try with this case where month is the 5th month, date is 12th, week is Saturday. So select Saturday. Distance is 478. Departure delay time, that is 20.694. And then we have maximum temperature, that is 89. Precipitation is 0. Average wind is 7.7. And scheduled turnaround time is 39.13. Give it. Now click on submit. So this given information, it will be pre-processed at the backend. It will be fed to the train model, and then train model will be giving us a prediction. So first we will be getting the classification, whether the flight will be delayed or not. If it is not delayed, it will not use the regression model. If it is delayed, then it will use a regression model and predict the estimated delay. So one time arrival, no significant delay. Now let's try with other case. Click on close. Now let's try with class 1. Apply filter to it. Click on OK. So let's check with this case where month is 7th. Day is also 7. Day of the week is Friday. Distance is 2498 miles. Departure is 58. Maximum temperature is 86. Precipitation time is 0.03. Average wind is 13.172. And scheduled turnaround is 75. Now click on submit. And here we got the prediction that it is delayed. Flight will be delayed. And the estimated time delay is 47.55 minutes. So flight will be delayed for 47 minutes. Now let's check with one more case. Let's check with this case. Month is the 6th month. Date is 30. That is day of the month is 30. And day of the week is also Friday. And distance is 2,402 miles. Departure delay is 11 minutes. 79 is the maximum temperature. 0 is the precipitation. And average wind is 6.604. And scheduled turnaround value is 47. Now click on submit. So here we got the prediction that it is delayed, and it will be delayed for 28.38 minutes. Now let's check with this case. Click on close. So month is 2nd month, delay of the month, that is day of the month is 17. Monday it is. Distance is 472 miles. 102 is the departure time. Maximum temperature is 34. 0 is the precipitation. Average wind is 7.5600934. And 81, that is 80 is the schedule. Now click on submit. So here if you see, flight is delayed, that is for 97, that is 96.72 minutes. So flight will be delayed for 72 minutes. Here we have the disclaimer. So it is not used for real life situations. Now close it. And now let's check with one more case. Let's check with this case where month is 10, Wednesday, it's Wednesday. Sorry, month is 5, day of the month is 10, day of the week is Wednesday. Distance in miles are 569. Departure delay is 110. Maximum temperature is 76. 0, 4.605574 is the average wind speed. And scheduled turnaround is 74. Now click on submit. And here we have prediction that flight will be delayed for 106 minutes. So this is how you need to execute. Now close it. Now let's check with the graphs. So let's check graphs of classification. Click on classification. Here the first graph which we have is a sample outcome graph in a pie chart diagram. So orange color represents delay and this blue represents not delay. Here if you observe there is class imbalance, that is delay cases are more than the not delay. That is why we are using k-means mode technique. And this is the balanced data set. After applying k-means mode technique, here you can observe both of them are in the equal samples. And here we have heat map, which shows the correlation between variables. And here we have correlation matrix. This is the correlation matrix. And here we have accuracy score, where on x-axis, we are having all the algorithms that we have trained, and on y-axis, we have accuracy. And here we have precision. Close it. And here we have recall score, FN score, AUC score. And here we have explainable AI SHAP value. Close it. Let's check with regression. So here the first graph we have is the delay distribution. So this is the line graph, where on x-axis we have arrival delay in minutes and on y-axis we have frequency. This is flight arrival delay distribution graph. And here we have confusion matrix. Sorry, this is correlation matrix. Now close this. And here we have MSE score. Here on x-axis we have all the models that we have used, and on y-axis we have mean squared error value for each algorithm. And here we have RMSE score. This is the RMSE score. Close it. And here we have MAE score. Here we have R2 score. And in the last we have SHAP explainable chart, where it shows the feature importance in predicting particular value. So close this. Now click on sign out. In this way, just by giving the required details to the application first, it will be predicting whether flight will be delayed or not. If the flight will be delayed, it will tell how many minutes it will be delayed. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.